In this video, I will show you how to create straight line graphs. Now, on an exam paper, if you come across anything like this, you've got some empty boxes with an equation and a grid like this, you are going to draw a straight line graph. So let's start off with this one. Here's what we're going to plot. I always start off from the right hand side, never from the left hand side. I start from the right hand side because the numbers are easier, they're positive. So what you're going to do is substitute each and every one of these numbers into the x. Remember, these are all the x values and we need to work out all the y values, So let's start with the 3, this one here. Put the 3 in here, substitute 3 inside here, so you'll have 2 times 3, which is 6, and then the 6 take away 3 gives you 3. Next, substitute the 2, that 2 there, into the x. So you'll have 2 times 2, which is 4. 4 take away 3, 1. Next, substitute the 1 into the x. 2 times 1 is 2. 2 take away 3. 2 take away 3. Check the number line. 2 take away 3 is minus 1. Right, now replace the x with 0. 2 times 0 is 0. 0 take away 3. 0 take away 3. Check on the number line. It's minus 3. Right. I could substitute the negative ones, the negative 2s and so on, but I can see there's a pattern emerging here already. I started off with a 3 and it went down to 1, then it went down to minus 1 and then minus 3. So if I quickly show you a number line here, right, 3. So I've got 3 there. 1, negative 1, negative 3. You can see there's a pattern, there's a gap of 2. So there's a gap of 2 there, there's another gap of 2 there, there's another gap of 2 there. There should be another gap of 2, negative 5. So I'm going to put negative 5 here. And again, negative 5, another gap of 2, that's negative 7. Negative 7. So you had negative 1, negative 3, negative 5, negative 7. It's like odd numbers. Negative 9. So I've got my values here. I need to plot them now. X's go along the corridor. The Y values go up the stairs, up and down the stairs. So 3 along the corridor, 3 up the stairs. That one's done. 2 and 1. 2 along the corridor, 1 up the stairs. 2 and 1. 1 along the corridor, 1 along the corridor, negative 1 down the stairs. So 1, negative 1. 0 and negative 3. 0 along the corridor, there. And then negative 3 down there. You can see I'm doing this right so far because it looks like these crosses are going to form, be sitting on a straight line. So far I know I'm doing this right. If suddenly you end up putting a cross up here, I mean, you cannot have a straight line going like this and then bent up there. So you know you're doing something wrong. So look back again. Where am I now? I've reached, so negative 1, negative 5, negative 1 along the corridor, right there, negative 5 down the stairs. Negative 2 and negative 7, negative 2, negative 7, negative 3 along the corridor, negative 9. All I've got to do now is join them up. Should be on a straight line. If not, check your values again, check your calculations. Right, this is not called a line of best fit. This is not a line of best fit. If you're thinking about line of best fit, you're thinking about scatter graphs. That's a separate video. Now I could use this line of best fit to work out other values. So for example, if x is equal to 2 and I want to know what the value of y is, I would find x equals 2 on the x-axis here. Keep going until you hit the graph and then turn left. So when x is 2, y is 1. Oh, but we knew that already, didn't we? We had those values on the table. When x is 2, y is 1. X is 2, y is 1. Let's try and find something that's not in the table. So for example, if I'm using x as something else, let's try 1.5. Try decimal. So you look for, now I'll try 2.5. 2.5 is right here. 2.5. Keep going up. Hit the graph, turn left. So when x is 2.5, y is equal to 2. And I can quickly check with the calculation here. If I replace the x with 2.5, 2 times 2.5 is 5. Take away 3. 5 take away 3 is 2.